Hello, sir.
Yes, I said, why are there just three of you? Hey,
Please, I don't know. Maybe
the three of you includes myself. Okay, no problem. Let's begin our class. Welcome to today's class. Today we will be talking about functions. Okay, so we will look at functions, what they are, and how to build functions. We will, discuss the anatomy, or we will open up a function and see how a function looks like. We will also look at user-defined functions, functions that you as a user, you create. And then we will look at value returning functions, functions that return a value to the user. And then we'll look at parameters, what we call actual parameters, and then what we call formal parameters, or the arguments, and then parameters. Then we'll look at identifier scope, the scope of a variable, global scope, and then local scope. So what basically is a function? A function is a group or section of your code which does something specific. When you have a part of your code which does something specific and you group it into a block, so such that it has a name, we call it a function. Okay? So when you have a section of your code which is doing something specific, okay, and then you put it into a block, and that block is given a name, we call that a function. Are we okay? Okay. Now we use functions, or we design functions so that we can manage the code. Okay, so that we can do specific parts of the code. Oh, sorry. Can you see my slide? Hello?
yes, sir.
You can see my slide, right? Okay, sorry. For a minute there, it went off. So yeah, so we do functions so that we can have parts of our code where we can manage. Okay, if there's a block or a piece of the code which is manageable, or it is together in one place, then it is easier to work with it, or it is easier to make it do the things that we want it to do. Okay, functions help us to group our code, or to write our code in groups, so that if we need to reuse code we already have written, we simply take that code and we reuse that code. Okay? So one key thing to note is that instead of writing all your code in one long program, functions allow you to break that code into parts which are doing something specific. The idea or the advantage they give you is that if you break them into pieces, then if there is a problem with one part, you can quickly replace that part. Okay? Also, if you have a part of your code which is doing something very important and you need it in another program, you can quickly reuse that piece of code as well. It is also very important to break your program down into functions, because you can easily debug your program. Okay, it is easier to find an error and correct it if your code is smaller than to find an error and correct it if your code is one long line or long program. Okay, if it's a very long program, it takes a while to find the error. But if it's a very small program, or the program is broken down into small pieces, then you can just take the part which is the problem out, correct it, and bring it back in. Okay, that is what some of the advantage of functions are. Okay, so like I was saying earlier, functions help you to break your program down into small pieces. We call that, in programming, we call it modularity. Modularity. Okay, we divide the programs into manageable, smaller pieces. Another important thing, like I was saying earlier, is that we can maintain the program if it is smaller. Maintenance means that you can correct or debug it. You can modify it if you need to make any changes. And then you can isolate and test the program if there are any errors. Then another important thing to take note is that functions help you so that your program can keep all the code and the variables local. Okay, we'll talk about scope very, very soon. Okay, so scope is also one of the advantages of functions. They help you to keep the scope local. And then functions are an important part of object-oriented programming, and most especially all the types of the good things about programming, because they help us to encapsulate the logic for particular things. Okay, so these are some of the reasons. There are more, okay, but these are some of the reasons why functions are important to or in programming. Any questions? Yes, any questions? Hello? Am I still online?
Yes,
No questions?
Yes, sir.
Okay. Okay, let's go on.
Hello, sir.
Yes, sir. Yes, sir.
So please, does the functions helps you to read or like to get the easiest understanding of your coding?
No, functions help you to group your code into specific parts of your code. So, for example, if there's a part of your code that is doing something specific, okay, like for example, if there's a part, maybe your code is doing calculating the area and the circumference. Notice that the area is something specific, and then the circumference too is something specific. So what will happen is that there will be a piece of your code which is doing only area. We can put it inside one function. And there will be a piece of your code which is also doing only circumference. We can also put that in a particular part of your code, which is called a function. Okay. And so what it will do is that if you put it inside, or if you have functions, you can easily go and correct it if there's an error with the area. You know where to go. You know which one to correct. But if you wrote everything together, then even though you can find the error, it will be a little bit more harder to find how to correct the error. Okay, so that is the key issue about functions. I hope I've answered you.
All right, sir.
Okay. Okay. Please give me 1 minute. I will turn back to the call. Okay. Thank you so much. Okay, so as I was saying earlier, now there are two main kinds of functions. We have what we call user-defined functions and built-in functions. So we start with the built-in functions. Now, a built-in function or a predefined function is a function which has already been written. Okay, they have been pre-written, right? Written to be part of the programming language itself. So, for example, if you go and get Python, or you go and get C++, or you go and download Java, there are pre-written functions already written inside these programming languages. They are contained in a file or in a library we call the standard library, okay? And they help you to do things like if you want to print, for example, if you want to print something to the screen, or if you want to collect user input, okay? Or if you want to maybe calculate maybe square root, okay? Or if you want to maybe calculate maybe something on the screen, all of these have pre-written functions. I have some examples over here to show you. So if you grab any programming language from the programming languages website and you install it on your computer, you have access to certain pre-written functions. They are part of the programming language. They help you to make your work easy. In addition, you, the user, can also write your own functions. We call that user-defined functions. So if I'm someone who occasionally does something on my computer, okay, I do a lot of work on my computer or with my computer, and as such, in my programming, I want to maybe write a function so that every time if I want to come back to that particular function or the work that function does, I'll easily do it quickly. Then I write that as a function so that I can easily do that particular task I want to do. Okay, so we call that a function. In fact, if you are writing any piece of code, you will usually break the code down into functions so that you can quickly get some of the work done. Okay, so we call those ones user-defined functions. And then the ones that we write them, the ones that are written for us and come with the programming language, we call them pre-written, or we call them built-in functions. So the ones you write are called user-defined, and the ones that are written for you are called pre-built functions. Okay. Now, in order to create a function, you need to declare it. Okay, so in programming, whenever we're creating something, we call it declaration. Okay. Whenever we are creating something, we call it declaration. Okay. So in order to declare a function, you need to do two important things. Number one, you need to declare the function. Okay. Then you need to do what we call the definition, function definition. Okay. The function declaration is the part of the function which contains the name of the function, the return type of the function, and the parameters, if there are any, of the function. So for example, an example is that if I want to create a function called sum, okay, I need to tell the computer that I'm creating a function called sum. Sum is going to return an integer. So I need to do maybe something like this. This part of the code, which contains the name of the function and contains the return type of the function and the parameters of the function, when you have this part of your program, that is what we call the declaration. Okay. Then the second part of the program is the part of the function which contains the declaration and the actual code, the code which forms the body of the function. Okay, so the top of the function or the part of the function which contains the name and the return type and the parameter list, that one is called the declaration of the function. Then the part of the function which contains the declaration and the body of the function is what we refer to as the function definition. Function definition. Okay. So let's look at the example we have over here. So in the example we have over here, okay. In the example we have over here, in the example we have over here, this part, or number one, is an example of a function declaration. Okay. In some programming languages, we call this the prototype. Okay. Okay, sorry. The function prototype. It means it has the data type or the return type. It has the name of the function. Then it has what we call the parameter list or formal parameter list. The return type, the name, the formal parameter list. Then when we write the full function, okay, the full function, look at it. We have the declaration plus the body of the function. Okay, this is called the body. Okay, this is called the body of the function. We call this one together the definition. We call this one together the definition. We call this one together the definition. Any questions? I thought I've answered this. Hello, any questions?
No, sir.
You understand the difference between the two, the declaration and then the definition. The declaration only has the head, or what we call the prototype, and then the definition has the prototype and the body of the function. Okay, so let's proceed. Now we'll come and talk about this one. This is how we call the function, but I'll come and talk about it in the next section. Okay. So probing further. Okay. Okay. So as I was saying earlier, now let's look at the various parts of the function definition. Let's look at the parts of the function definition. So we notice that for the function definition, we were mentioning something called return type. When we say return type, we are simply referring to the value that the function will return. Okay? So the value the function can return can be an integer, can be a decimal, okay? Can also be a float, can be a character. It can also be a string. It can even be a Boolean. It can be, I think we got character. And then for functions, there's a special type we call void, okay? So it can also be a void. It only applies to functions, okay? So we can have void, we can have Boolean, we can have int, we can have double, we can have short, we can have float, character, string, and so many things. Okay, these are the return type we can have in functions. Then functions can have a name. Okay, so functions have a name. So the function name should be descriptive. It means use a name that at least gives you an idea about the description gives you an idea about the name gives you an idea about what the function should do. So, for example, if the function is supposed to add everything, then that function should be called add, right? So we call that function add. Okay. If the function is supposed to multiply everything, then we call that function multiply. Use a name which is descriptive. Okay, at least gives you an idea about what the function is doing. Then the next one is called the formal parameter list. That one, if we want to pass any data, to the function, we use the formal parameter list to pass data. To pass data to the functions. So that is what the formal parameter list is. We'll come to learn how to use it as well. Then the body of the function refers to the part of the function which provides or has the statement for what the function is supposed to do. Okay. So let's delve deeper. Okay, so as I was saying earlier, you can see the various types. So you write the return type first. When you are creating a function, you need to write the return type. So here you put something like an integer, or you put a character, or you put a string, or any of the other ones. Okay. Then you put the name of the function. The name of the function. For also, like I was saying, then you put the formal parameter. It must always be in a bracket, okay? As for the parameter, it must always be inside the brackets, okay? Then you put the body or the code that forms the body of the function inside that one, okay? Then, so that is the key thing that you do over here, okay? Any questions? Hello? Okay, let's look at some examples. Okay.
We are following.
Okay. So number one, first example. So let's look at the first example. So the first example, the name of the function is called add. Okay. What are we adding? We are adding parameter called A and a parameter called B. So the parameters are two. A is an integer, B is also an integer. And look at the body of the function. The body of the function is a return statement. So we are returning A plus B. The data type or the return type of the entire function is what? Double. So we are returning a decimal. Okay. Example 2. The name of the function is what? Print hello. Look at the return type. The return is what? An integer. And then look at the parameters. Here, there are no parameters. There's 0 parameters. So you can have a function without any parameters. It's possible to have a function without parameters. Then look at the body of the function. The body of the function has 2 lines of code. So it's not by force to have 1 line of code. You can have as many lines of code as you want. Now, here to notice that we are returning something. Look, we were returning in the first one. We are returning the second one. We are doing that because of this thing over here. If you have integer or double or character or string or any of the return types, you need to have a return value. That one is part of the rules in programming. Okay? So if you have any data type, you must return a value which is equal to the data type. Okay, so for example, if you have a decimal, then if the function is a double, then you must return a decimal. If the function is an integer, then you must return a whole number, and so on and so forth. Okay. Then look at the example 3. Example number 3, the name of the function is display message. Look at the data type. The data type is what? Or the type is what? Void. Now look at the code inside. The code inside does not have any return. Look at the body. It's only one line, no return, because of void. When you have void, you don't return anything. But without the void, you must return something. Okay? So it is very important that you understand that with the void, you must return, you are not forced to return anything, but without the void, you must return something. Then look at this example 4 over here. So the name of the function is called ans. Data type is what? Void. And the parameter list are 2, A and B. They are both integers. Look at the body of the function. There is no return type in the body of the function. Why? Because of void. Because data type is void, we don't have any return type. Are we okay?
Yes, sir.
Okay. No questions?
Sir.
Yes, sir.
Let's look at the second example.
Yes.
The function is int print hello, write hello world. I know hello world is a string. So why didn't the programmer go ahead and say function string print hello, then return hello world? But
you cannot. Okay. So it's just an example I wanted to use to demonstrate. Okay. It's just an example.
Okay.
Yes.
Thank
you. Thank you for forgiving me.
Okay, sir.
Just an example. Okay.
Okay.
We'll come to the actual thing very soon. Just an example.
Okay. Yes. Okay. Now, lastly, let me also find out. Lastly, when you look at normally when you are teaching us these things, I do look at it at those that I know in Excel. If you look at Excel function, let's say equal average, then B2, let's say plus B3. Now in Excel we call those in the bracket as the arguments. I don't know. Can we, without calling it parameter, can you call it arguments? The ones in the bracket.
They are not. They are called parameters. That's their name. We'll come to the naming thing soon. Okay.
Okay, sir.
Yeah. There's a place where we call them arguments, and there's a place where we call them parameters. The ones over here in the definition, they are called parameters.
The parameters. Okay, sir. Thank you.
Yes, please. Yes, please. Okay. Any other? Okay, so as you probably thinking about all of these, let's proceed. Okay. Now, when you create the function, you have done well. You have created a function, but you are not done. The next thing you must do is to call the function, because the function, the truth is that you can call a function more than once. You can use a function. You only use the function when you call the function. Declaring the function, defining the function is good. But when you do that, you are not done. In order to use the function, you must call the function. A function call is a statement that uses the function in your program. Okay? So it is also very, very, very simple. How you call a function is that you write the name of the function, then you follow that name with the arguments, the thing the gentleman was talking about. Okay, so we'll see it very soon. Okay. So for example, let's look at the example. So for example, we have a function called print message. The data type of this function is void. Look, there are no parameters. You can see that, no parameters. The body of this function is a single line print statement, which is saying this is a function. Put. Okay? So when you call this function is only supposed to say this is a function. Now, how do we cause this function to be called? Or how do we run this function in our main program? Okay? So how do we run this function in our main program? Number one, we need to type the name of the function, followed by the brackets. Brackets is what tells the computer you are dealing with a function. Okay, so it is important that you indicate with the brackets that you are dealing with a function. Are we okay?
Yes, sir.
Hello?
Yes, sir.
So writing or typing or using the brackets will tell the computer you are dealing with a function. Okay, it's very important. So this is the line that's what we call the function call. This line, that's the function call. This one will cause the computer to go and run the program. Finish running the program and come back and continue what is left. When we get to line 3, we will stop running the main program, go and run the function, and then when we are done running the function, we return back and run the main program from line 4. Are we okay?
Yes, sir.
Okay, so that's what is going to happen. It's not very complicated. What it means is that every time I write print message, the computer will go and run print message and return with an answer. It means I can write print message more than once. More than once. It will run it as many times as I call it. Every time I call print message, it will run print message and return back to the main program. Let's see if I have more examples. So I have another example. So here I have a program that has 2 functions. Function first and function second. Then inside my main program, I have line 3 and line 4, which are function calls. This is how you call your function. You need to write the name of the function followed by parentheses. The parentheses are empty because look over here, these ones are also empty. So because the parameters are empty, the arguments are also empty over here. The ones that appear over here are called parameters, okay? And the ones that appear over here are called arguments. So please take note of that. We're going to talk about it very soon. Okay. Now, what is happening? What is happening is that if or when we run, the computer will always run the main program only, okay? The computer will always run the main program only. But when it gets into the main program from line 1, it will come and run line 2. Then on line 3, it will see that it is being instructed to go and run the function called 1 first. Sorry. So it will go and run everything in here and then return back. When it returns back on line 4, it will see that go and run second. It will go and run second and then return back control. Then continue to line 5 and then line 6. So the computer goes to run the function as many times as we will print it, or we will use the function. Another example. We have a program. This is our main program. Like I said before, we always run the main program. Okay, so we are going to run this main program. So running this main program, we start with line 1. We start. Then line 2, we create a variable called b. Line 3, we put 10 inside the variable called b. Then line 4, it says write. But the computer says that this one is a function. Because we don't know the answer, or we don't know what the function is telling us, we need to go and run the function. So we run the function. When we run the function, it says return 5. What it means is that wherever you see the brackets, you need to put 5. So we have 10 plus 5. So we will see 15. And then we will end the main program. So that is what we are depicting over here. Any questions? Okay. If there are no questions, then we proceed, or we push ahead. Now, how do we pass information to a function? How do we pass information to a function? Okay. So in order to pass data into a function, we use arguments. The gentleman was talking about this one not long ago. Arguments are the data that we pass into a function. So for example, if we have a function called print amount, and print amount takes as parameter a double variable called AMT. Then somewhere in our code, if we want to pass or to give a number or a value to this function print amount, we will simply need to call the name of the function, which of course everybody here knows it's called print amount. Then inside the bracket, we will indicate the number we want to pass. Remember, it's only one number over here. So it's just one decimal number. But this value over here is what we call the argument. Okay, so the argument is the value that we send to the function. Then when you see the function definition, like you are seeing over here, the header plus the body, the value which follow the bracket or are in the bracket like this, they are called parameters or parameter. So please take note of them. Any questions? Parameters and arguments. Arguments are in the function call. Parameters are in the function declaration or function definition. Any questions?
Sir, so meaning without the function definition, there's no way the main program can run.
If you have a main program which is calling a function and you have not created the function, neither have you done anything about the function, there's no way you can expect the computer to go and conjure a function. No, it will not run. You have to create the function for the computer to use the function. If you don't create the function, you cannot use the function.
Okay, sir. Thank you.
Yes, you have to create it. It's like you are a man without any child. Then maybe you are sitting inside and you are calling the name of a child. Kofi, Kofi, come here. Kofi, come here. But you have not created Kofi. So how will Kofi come? Kofi needs to be there before you can call Kofi to come. That is the analogy, okay?
Thank you, sir.
You're welcome. Any other question? Okay. So think of the parameter as maybe children, okay? When you just say children, you've not said anything actually, but you have a placeholder for children. The parameter is a placeholder. It is holding the place of the data that you want to send to the function, okay? Whilst the argument is the actual data. Kofi is the actual child. But if you say you have children, children is a placeholder, okay? But Kofi is the actual child. Okay, let's look at another example. So in this example, we have our main program, okay? So in our main program, we write passing value to display value. Then we call the function called display value. Display value, remember, is located over here. So that is the display value. It takes an integer parameter. The value over here is called a parameter, okay? Then notice that we have passed 19, sorry. So 19 over here is the argument. Is the function argument. 19 will be put, 19 will be put inside the variable called num. Okay, we put in 19. So that with a value, so that this print statement can run and says the value is 19 and function. Then we will come back to line 4, which will say back to main and then end the program. Is it understood, please? Am I still online?
Yes,
Hello?
sir.
Okay, please let me get feedback or else I'll think I'm offline. Okay. Okay, let's do another example. So we have a function called add. What add is doing is that add is adding two integer variables. Okay. The parameter A, parameter B. They are both integers. Now, in order for add to work, you have to do a function call. Okay, so this one is the function call. Remember, we said function call, you write the name of the function and then you pass or you give it the value if there are any. Here, we have created two variables. I'm sure num1 is an integer variable, maybe filled with 10, and then num2 is an integer variable filled with maybe 15. So at the end of the day, when I do num1, num2, what I'm actually doing is that I'm putting 10 inside A and then 15 inside B. Then when I do A plus B, I'm simply doing 10 plus 15, which is what? 25. Are we good?
Yes, sir.
Okay. So that's an example of how it can be used. Now, what is the name itself? So parameters are actually called formal parameters or formal arguments. And then arguments, the one you pass to a function call, they are rather called actual parameters or actual arguments. So when you are writing the function definition, the parameters over there are called formal parameters. But when you are writing the function call, the parameters you write are called actual parameters or actual arguments. Okay, let's proceed. Any questions? No questions? Okay. Now, when you create a function, okay, and you pass a value in the function call to the function, what the computer does is that it automatically makes a copy of the data. The copy of the data means that the original data cannot be altered. The original data remains the same way it is, but the new or the copied data, you can change it. You can manipulate it. You can do something to it. Are we okay? We call this kind of idea pass by value. Pass by value. Okay, it's a way to access the parameters of a function. Okay. So in the function call, when we pass any data to the function, that data is copied, and a copy is given to the user of the particular application or program. Okay, that user is what? The function itself. Okay, let's look at an example. So for example, over here, we have our main program, okay? Look at our main program. Oh, sorry. So let's look at our main program. We start the program. We declare a variable called num. Remember, num is an integer. Then we set the num to 14. So we put 14 inside num. Then we write num is, then we'll see num. So num is 14. Then we call a function with the value of num. What's going to happen is that a copy of 14 is going to be made and sent to the function. So over here, sorry. So over here, you have 14 over here. Change me, let's see change me. Okay, remember we said that it will go and look for the function. So remember, change me int val. Val contains the number 14. Okay, so wherever we see val, we put 14. Then over here, we try to demonstrate that you can do pass by value, and pass by value will change the value of the copy and not the original. Okay, so we change what is inside val. Look carefully. Important. Okay. So we change what is inside val. Okay. The new value of val is what? 19. Then we write the new value of val. But remember, over here, the num or val, num has not changed. Num is still 14. Still 14. So when we are done with this and we come back and we print this one, we are still going to see 14. Then line 7, we are going to end the program. Are we okay?
Yes, sir.
Okay. Now, as I was saying earlier, functions sometimes they have, instead of having void type, most times they have a data type. Okay, they have a data type. So if the function has a data type, then it must return a value. Okay, functions must return the value. Now, remember that as soon as you write the return keyword, the function must end. Okay, so please take note of that. Okay, as soon as you write the return keyword, your function must end. So if you are using a function which is what? An integer function, or a float function, or a double function, or any function which is character or Boolean, okay? Or Boolean, okay? Or any of the other types, then you must have a return value in there. Okay? So please take note of that. So for example, in this example, you can see that the function is an integer function. So we are returning the results. Result is an integer. Please take note of it over here. You can see that. The data type must match. Okay? The type of what you are returning must match. So it's important that if your function is an integer, you return an integer as well, okay? It's important that if your function is a floating point, you return a floating point. But the moment you type return inside your function has ended. So you must not have any code after return. There must not be any code after return. Are we good?
Yes, sir.
Okay, thank you very much for responding. Okay, so for example, if I have a function call over here, okay? And this function sum, I'm giving it two values. Maybe there's a value called, maybe the first value contains maybe 25. Second value contains 15. What happens is that if I write this line of code, then 15 will be copied and given to num2. Okay, so num2 contains 15. Then num1 will have 25. So 25 will be copied and given to. Okay, so 25 will be copied and given to num1. Okay, then what it means is that everywhere within sum that I see num1, I can replace it with what? 25. And everywhere that I see num2, I can replace it with what? With 15. So it means I'm adding 25 plus 15. Which answer will be 40? Okay. So it means if I see return, it means return 40. Okay. So 40 is what will be returned inside total. Is it understood?
Yes, sir.
Hello? Okay. So that is what happens when you write a function that has a return. When you say return, the function will return whatever it is that the sum or the subtraction or the division or the multiplication or the value is. You could have simply done return 0. Okay, you can simply do return 0, which is also correct because 0 is an integer, or return 1, or return 2, or return 3, or any whole number. Okay. Okay. So I want us to do something. Since you guys are not asking any questions, I want us to do something very quickly. I want us to together write a function which has two parameters. Okay. So we are going to go to the whiteboard. We are going to write a function which has two parameters. The function is an integer function, and the function, what it does is that the function returns the multiplication of the two parameters. Okay. So what the function does is that the function will return the multiplication of the two parameters. So first, because we are writing in pseudocode, for my pseudocode, I prefer or I like to write the word function. Okay. So that the students know that I'm writing a function. Okay. Then the data type of the function, of course. So let's make that function an integer. Then let's call that function multiply. Then, of course, we said that it takes two parameters. So let's make sure it takes two parameters, A and B. Then what it should do is that it should multiply the values of the two parameters and return them. Because of int, we need to return. Okay, so you can simply do return A star B. Okay, that's what we said the last time, that if you want to do multiplication in programming, you have to use the star. Okay, if you remember. Okay, then we do, of course, the last line, which is what? End function. It's not important, but I just want you to know the start and the end of everything I write. So have you guys seen what we just did? Very, very simple. You can see it's very, very simple. The data type, the return type, the name of the function, the parameters, and then over here, of course, the body of the function. Are we okay?
Yes, sir.
Okay. No questions? Okay, I can say that since there are no responses, it means no questions. Okay, let's proceed.
So please, what if the int in A is 5 and the int in B is also 5? I
Yeah, so
think
it's
there.
5 times 5.
Oh, okay.
That's it. And then the answer will be returned. So return means send the answer back to whoever is calling me. Okay. So for example, you may have a program or you have a program, and in that program, if you want to use this one, you must call multiply, and then you must give it 5 and 5. Okay. So that what your computer will do is that your computer will make a copy, like I said earlier, we call this pass by value. Okay. So we make a copy of this and put inside the first one, and you make a copy of the second one and put inside the second one. Okay. So A contains 5, B contains 5. And so when you call us, we return what 25. Okay. 5 times 5 is 25. Okay.
Yes, sir.
Yes. Any other question? Those people who have been writing, hey, what is okay? Let me just keep quiet. Okay, let's go back to let's stop our presentation and then go back to the whiteboard. Sorry, go back to the slide. Okay, now let's talk about scope of a variable. That's one of the last things we'll do. Okay, what I want us to do next week is that I want us to solve questions. So on Sunday, when you come, questions. We'll keep solving so that I know that you are prepared for everything. Okay. Now, when we say the scope of a variable, we are talking about the place that the variable can be seen and used. In programming, the mere fact that you have created a variable doesn't mean you can use the variable everywhere. Okay? So we have various types of places that when you create a variable, you cannot use them in other places within the program. Okay? So let's examine what the scope of a variable is. Now, scope is very important because it is the scope that helps us prevent conflict with the names, so that you will not create a variable called int A, and then you have another variable called int A, and then another variable called int A. Okay, if you do something like this in programming, it will not work. But because of scoping, we can create 3 different int A variables in the same computer program, and it will work perfectly well. If you just do it normally, it will not work. But because of scoping helps us to know where this one is, where this one is also located, and where this one also is located. Okay, so scoping is very important. Then let's go to the next one. Next reason why scope is important is because it helps us to manage memory by cleaning up the variables. So you see, some variables are short-lived. When you create them, we use them and we destroy them, and we free the memory for other things. Other variables too, they persist in memory even when we stop the program. So the scope of the variable will help us to distinguish or to differentiate which of the variables or which of the types of variables we are dealing with. Okay. Then the scope also provides security by helping us to limit access to variables within our program. Let me show you what I mean. Now, there are 3 main kinds of scope in computer programming. Okay. We have what we call the global scope. Global meaning that everybody can see it, everybody can use it, everybody can access it. Okay. So these variables can be accessed from everywhere in your program. There are some variables you want to make global. Okay, not everything, but some of them. Then we have local scope. Local scope means that it is only located at certain parts of your program. Usually, they are found inside a function. Local. They are only found inside a function. Local. So when you are inside that function, you can use them. But when you go outside the function and you are inside the main computer program, you cannot use them. Those variables only exist inside particular functions. Okay? Then we have block scope. Block scope is variables, they are like local variables, but the only difference is that they exist inside particular blocks. So for example, if I have a for loop and I create int I, set it equal to 0, I must not be more than 5, I plus plus. Notice that the place I have created this function, this I is an example of a block scope variable. What it means is that the computer can only remember and use I when it sees the for loop. Outside the for loop, the computer does not know I only lives inside this for loop. Within your main program, the computer does not see I is only existing inside your main program. So that one too is there. We call it block scope. When you create a variable that only exists at a certain block or within a certain block of your program. Okay. So please take note of that. Let me show you an example of local scope. So I've already explained what local scope is. So let me show you an example. So for example, I have a program where I have created a variable called num. Okay, set it equal to 1. Now, this num only exists from start to end. Once the program starts and ends, num does not exist anywhere again. It's called local scope variable. The scope or the place we can see and use num is only available in local. Okay, it is local to this particular program. Okay, so please take note of. Now, there is another num. I can create another num in the same program. This time around, it is inside a function. And here too, this num only is seen by the computer when you call the function test. So num or num is local to the function test. This num is different from the first num. The one on line 2 inside the program, the main program, it's even though they have the same name and they are the same data type, they are two different things. So the computer uses scope to help it to understand where this one is located and where this one is located. Okay, so that they don't conflict with each other. Now, this num, like I said, is only visible within the main program. And then this num is only visible within the function called test. That's the key difference. You can create within the same program, you can create the same variable, label it, give it different values, use it in any way you want to use it, provided that they are local to the part of the program that you have created them. The moment you create a variable which is not local, 2 or more of them which are not local, you have an error in programming. So please take note of that. Then global scope is when you create the variable so that everybody can see it, everybody can use it, and everybody can maybe access it. That way, when you do your variables like that, it means you can only create one of such variables, okay? So here we have a variable, a global scope variable called message. It is global scope because where the variable is appearing, everybody can see it, including grid, including your main program as well. Your main program can see this. Grid can also see this. So it is important and it is global. When I call print message or write message, it will go and print this one. When I call write message, it will also go and print the same thing up there. So that's why it's also global scope. It is global scope because it is also created before everything. So everything can use it. Are you with me? Hello?
Yes, sir. Yes, sir.
Okay. So let me pause and ask if there are any questions. Let me pause. Are there any questions? Hello?
Aye.
Yes, sir.
Yes, sir.
Oh, no questions? Hey.
So far, it's understandable.
Understandable.
Yeah.
Okay.
And
Okay.
sir,
Yes, sir.
yeah, in fact, let me say this. The way you teach the programming is like elementary maths. In fact, it makes us understand it as you flow. Yes, that's why sometimes you don't ask questions because
Okay.
the time you
I'm
take,
glad.
you
I'm
take
glad.
your
I'm
time. In
glad.
fact, we are grateful. I like the way
I'm
you
glad. Okay. Okay.
I used to fear it, but you have made programming look like elementary maths for me. Thank you.
Thank you. Okay. Thank you. Okay. So last example, then we can call it end of class, and then we'll meet next week. Okay. So last example is an example of global variable as well. Look at where this variable is. So this variable is a global variable. Okay, because it is created up there on the top before your main program and before your function. So sometimes where you create a variable also has influence on whether it is global or local. Are you with me? It's very, very important. Where you create a variable also has influence. So when you put the variable at the very top before everything comes, then that variable is most probably a global variable. Everybody can access and see it. Okay, so here we have a global variable. Oh, sorry. When I touch the thing, no, then it stops. We have a global variable called num. And when we print num, because we have not created any num within, we have not created any other variable within the main program called num, it will go and print this one. Okay, to go and print 12. Okay, so we'll see 12. Okay, then inside the function, look at line 4. We are changing the value of num, but the change we are doing only affects function test. It only applies to the test. It doesn't apply to the global variable. That variable is still 12, whether we like it or not. But when it comes inside test, we have changed it from 12 to 50. This one only affects functions, tests. Okay, it doesn't affect the main program. Okay, so please take note of that. So when we print this one, we will see 50. Okay, when we print this one, we will see 12 because we printed this one, this 12, before we changed the 12 to 50. So please take note of the line or the place in programming. We work from top to bottom. So if something has happened at the top, it affects everything down there. But once you change something, you cannot, it also affects everything down that place as well. We will call it a day over here. I think the meeting in person next week. Okay, and so please take note of that. When you are coming, remember to bring my assignments, your names, index numbers, or in the groups on the assignment. The course rep will collect everything so that I can have access to them from the course rep. Any questions, then we'll close so that you can rest more before your next class.
Sir, thank you very much. You made mention that next week's face-to-face will be more of solving questions.
Yes, please.
Yeah, so I wanted to ask, what of we those who can't make it in person? How do we also benefit from that, please?
Chineke, my dear friend, that one, how will we, they say come, you say you won't come. So how will we, how will we do it? My dear friend, they say come, you say you cannot come. So there's not much I can do for you. Okay. We are meeting in person. You know, you've been to the school before, right? Hello?
No, sir.
Oh, those who were there, you notice that we cannot do the Zoom and we cannot do the Zoom and the in person at the same time. We can only do one at a time. So I'm sorry, we cannot accommodate. The best thing is to come. If you can come.
Thank you, sir.
If you can come, please. Yes. Yes, any other question? Hello, am I still online?
Yes, sir.
Okay, please try, if you can, try and come, okay? Because I think you at least need to, as for education, you need to, in Ghana, you need to, even if you are doing distance, you need to try and come, 1 or 2, okay? It's important, unless you have done everything possible and you still can't come. So let's try and do that, okay? But it's just, we are just going to, I'm just trying to make sure that your learning is going the correct way. So that's why I'm saying we're just going to solve questions. So we're going to try to make sure that your learning is going the correct way. I want to test whether the learning is going the correct way. Okay? That's why I'm asking you for to come. Okay?
Okay, sir.
Okay, so if in the absence of any questions, then we will call it a day, and then we will meet, God willing, next week. And do enjoy the best of the week. And thank you for being part of my class.
Yes, sir.
Thank you, sir. Bye.
Thank you. Thank you.